So today we're going to dive into rotations using Python. After watching this video, you'll be able to select a group of objects based on their name, add a material, rotate them about any point, and also rotate them individually about their own origins, just using Python code. There are definitely some pitfalls when rotating objects, and I'll cover some of the ones I experienced when recording this video. Okay, let's get started. You may recall from the previous video, we were able to generate this grid of different objects using the Blender Python scripting interface. If you haven't seen that video, I'll put a link in the description and I recommend checking it out. So before we get started, you want to go up to the Edit Preferences menu and make sure to enable Developer Extras and Python Tooltips. So this is the code that we created in the previous video. It's a triple loop over grid locations, and we create, depending on which iteration of the loop we're in, we're going to create a different type of object, either a cube, a UV sphere, a cylinder, or a cone. We're going to assign their location based on our position in the loop, which is set from object location up here. And essentially running that code generates this 3D grid of objects here. What we'd like to do next is actually rotate all of the cubes in a couple different ways. One thing to keep in mind is that every time you run this script, it's going to create a new set of objects. So we can see over here, there's 30 cones, for example. If I run this script again, what happens is another 30 cones get created and so forth. What we'd like to do then is at the beginning of the script, put in a little bit of Python code that will just delete all of the existing objects. So I always like to start by doing it manually. If we go to the 3D view, click A to select everything, hit the delete key, we can see all the objects have been deleted. Then we can go down here into the info window and we can see what command was used to delete the objects. So we can go down here to the info window, grab this command, copy that, paste it up here. So that's going to be the Python command to select all objects. And then the next command here, copy that, paste it in. And this is the Python command to delete all objects. So let's go ahead and run the script and see what happens. Right now, we don't have any of the objects. Now we see we have 30 cones. Yep, got it. And let's run it again. All right, this is terrific. We've got everything working the way we want, except for the meshes. What we notice here is there's all sorts of meshes being created every time we run the script. So if we keep running this over and over again, like we have 157 cones, we got to run it again. And yeah, like now we've got even more. Okay, so what's happening here? Why do we have all of these extra meshes? Well, these turn out to be orphaned objects, so they're not associated with any particular object, but the mesh still exists even after you delete the object. So there is a way to get rid of these, and we'll do it two different ways. The first way is right from the outliner. We can go up here in the filter, choose orphan data, and now we can see here are all the meshes that are orphaned. They have 0 users, and so we can safely delete them. There's a button up here that says purge. You hit that, say OK. And now we go back to the scenes view, or actually we were in the Blender file view, and those meshes, the only ones left are the meshes associated with the objects that we created. Well, let's take a look at the second way to delete the orphaned objects. So we run the script a few more times. We can go back here to the outliner, look at the orphan data. We can see we've got a whole bunch of meshes without any users. So now the second way is we go to the File menu, Clean Up, Unused Data Blocks. And let's go ahead and click OK. And we can see those are deleted. And if we go back to the outliner, we can see that we have the right number of objects, 30 of each. But of course, we'd like to do all this from the script. So let's go to the info window, and we can see that there's a command here called bpy.ops.outliner.orphans_purge. So that looks pretty interesting. So we can copy this command and paste it up here. And I don't think we need this argument that says num deleted. So we will delete that. And now if we run the script again, let's see what we've got. 30 cones. Yep, looks good. And how about meshes? Looks good. We'll run the script one more time. And one more time just for good measure. See if we have any orphan data. Nope. Perfect. Now, every time we run the script, we don't have to worry about deleting the objects. So that'll help us be more efficient as we move forward. But of course, we aren't interested just in deleting objects. Let's go ahead and rotate these cubes. First thing we want to do is to select all the cubes. We can do that a couple different ways, but let's do it by name. So we can see cone here. If we look at these objects, cubes all start with cube conveniently, C-U-B-E. So if we go over here, select pattern, and the asterisk or the star will match any letters or numbers. So if we type cube star, we can go ahead and hit enter. And we can see all of the cubes got selected, except also the sphere, which was selected before, stayed selected. And the reason for that is because we had this extend checkbox selected. So let's go ahead and uncheck this extension, hit enter. And now let's just make sure one more time. Select pattern, cube star, enter. Whoops, cube star, enter. And now all of the cubes are selected. So let's get the relevant command here from the info window. Looks like this is the one we want. I'm going to copy this one and we're going to paste it down here. Should probably put in a comment. Select all of the cubes by name. Paste this in. And I'm going to go ahead and put a comment up here just to be complete. Delete all objects and orphan data. So now if we run this, just for kicks, I can manually delete everything and start from scratch. So now if we run the script, we should see all of our objects with the cubes selected. Great, this is exactly what we need to continue on. And the next thing we're going to do is rotate all of the cubes. So if we go up here into the 3D viewport, let's look at the top-down view. You can do that by clicking the Z icon here. And if we hit the R key, which stands for rotate, we can see all of the cubes will be rotated about the Z axis. If you hold the control key down, you can do increments. So you've got, let's say, 45 degrees. So as usual, we'll go down here to the info window. Let's grab this command and copy it. Let's go over here and say rotate all cubes by 45 degrees about the Z axis. One thing you'll notice is that when we copy this command from the info window, we get a lot of arguments. We only actually need the value and possibly the orient axis. So I'm going to go ahead and delete the rest of these. Let's just delete that. And this should be all that we actually need. So let's go ahead and run this script again. Let me rotate these by some non-45 degree angle. We'll run the script. And everything is as expected. So all of these cubes are now rotated by 45 degrees about the Z-axis. Well, what about another axis? Let's try the X-axis. So if we put X in here instead, and we run the script, now we can see we've actually got the cubes rotated about the X-axis instead. But let's stick with Z for now. Run this one more time. Look at the top-down view and see that's exactly what we want. The next thing to notice is that the value here is not 45 degrees, but is instead 0.785398. That's because the rotate operator expects radians as the argument, and there are pi radians in 180 degrees. So part of the math module is a conversion function which will allow you to convert from degrees to radians. We can say from math import radians. And then down here, instead of value equal to 0.785398. We can say radians of 45. And now if we run the script and we look up here, that looks good. We can change this to something like 22.5 instead and see that we get the right result. So I would recommend using this radians conversion function all the time if you're used to working in degrees, or if you're used to working in radians, you can just directly put the values in there. So it might be nice if the cubes actually had a different material so they were easier to see when we were checking our rotations. Let's go ahead and add materials now. The first thing to do is let's grab a reference to all of the selected cubes. We can say store selected cubes in a variable. So we can say all cubes equal to, and we want to get the selected objects. Let's go over to the Python console and try to figure this out using tab completion. So we can say selected objects are part of the context. We should know that. So we can say .context, and if we hit the tab key, we can see some completion possibilities. So how about selected objects? All right, so this looks good. So let's select an object and then see what we get. Yeah, this looks correct. So let's go ahead and use this command. We're going to store the result of selected objects into all cubes. Let's go ahead and try this. If you use the up arrow key, you can get the same command that you had just typed previously. All right, this is great. And here we've stored it in the script in the variable all cubes, and we can use that later to set a material. Let's create a new material. We'll give it a color, and then we're going to assign it to all of the cubes. So you can actually directly create a material using the data interface as follows. So we can do this again from the Python console. So we can say ppy.data, and materials, so tab completion works here. New. So let's do a new material, and we're going to call it cube material, cube mat. All right, perfect. So now we have a new material called cube mat. Just copy that, paste it over here. We can actually look in the outliner and see here also that it's been created. And let's store a reference to that as well. So now that we have a new material, let's give it a color. The way we can assign a color is using the diffuse color property of the material. So we can say cubemat.diffuse color. So this takes an RGB alpha set of arguments. So we can say some red, some green, no blue, alpha equal to 1 so that we can see it and go from there. Now the final step is to assign the material to the cubes. So you can see on line 36 we have all cubes, which is a variable containing all of the cubes. So we can make a loop that says for each cube and all cubes, cube.data.materials.append cube mat. So this loop goes through each cube and appends our new material to the cube's list of materials, which is empty at the moment because we've just created it. So if we do this and run the script, we should expect to see all of the cubes have sort of a yellowish color. And there we go. So perfect. So now we have created a material, assigned the material a color, and then assigned that new material to each of the cubes we had previously selected. And now you might want to change that color, for example. So if we just select one of these cubes, go to the material editing, and let's change to blue. We can see all of the cubes now have the same, because they're sharing the same material, they all have the new color. So that's great. And just as a little bonus, you can see the command down here. If you really like the particular color, you can just grab these values and paste them into the script. Actually, let's try that. So instead of 0.8, 0.80, let's say we have 0.03, 0.19, and 0.8. All right, so now the next time we run this, let's just delete everything. We run the script, we should get blue instead. Excellent. Okay, so we saw how we can rotate all of these cubes about the z-axis. You can see they're actually rotating about the median point. But there's another mode that you can use. Up here, if you look at this menu item, you can say individual origins instead. Then if we hit the R key, each cube rotates about its own individual axis. So let's assign the rotation for each cube individually. We can do that in a loop, much like we did for the materials. So we can again say for cube and all cubes. And this time, instead of setting the material, we're going to set the rotation. Say cube.rotation Euler equals 0, 0, and then radians 45. And actually up here, I forgot we had changed this to 22.5, so let's change that back. And now when we run the script, we should see not only are the cubes rotated 45 degrees about their median, but also rotated individually. So let's see what happens. All right, so that's what we have at the moment. And actually, I made a mistake. What we don't want to do here is, so this is setting the absolute rotation, so we want to just set this back to 0 degrees so that here we can show you what happens. Okay, so now all of the cubes are back at 0 degrees individual orientation, even though the cubes themselves have been rotated by 45 degrees about the z-axis. And I think just one final thing I want to do in the script is I'd like it if all of these objects weren't selected at the end. So we can go up to the 3D window. We can hit A and then Alt-A to select and deselect everything. And so when we look at Alt-A, that's this command. So let's deselect all objects. We can paste in this command. And now if we go up here, let's just start from scratch. So we'll run the script one final time. See that none of the cubes are selected after running the script. And actually everything looks good. So let's go back to the layout view to see our handiwork. So now we can create objects, we can set their translation, we can select them and rotate them, all using Python. And then based on a subscriber request, I'll start looking into assigning materials maybe randomly to each object in the next video. If there's anything you'd like to see in an upcoming video, just let me know in the comments and I'll try my best to cover it. And if you enjoy this content, please subscribe, maybe hit the like button, and stay tuned for more to come. Thanks for watching.